My name is Abe Amoros. I am the Deputy Executive Director for Operations for the Pennsylvania Municipal League. John Brenner, our Executive Director, is en route from Washington right now, but he sent his very best. We want to thank Pennsylvania American Water for making themselves available this morning to discuss polyfluoroalkyls in drinking water, understanding the new regulation requirements. And of course, they're also known as PFAS, and these are forever chemicals, which are really pollutants in our water. And today, Pennsylvania American Water is going to talk to you a little bit about what the topic is, how municipalities can prepare themselves, and how we can keep members of the general public safe in this regard. Of course, as elected officials and appointed officials, as staff members in our municipalities, public safety, of course, is tantamount to providing those public services. So I am joined just to turn it over right now to Jennifer Friel, who is our Strategic Partnership and Program Manager. And again, I want to thank Pennsylvania American Water for making themselves available this morning. And I want to thank all of you for attending this session as well. Jen?
Thanks, Abe. Yeah, my name is Jennifer Friel. I'm the Strategic Partnership and Program Manager here at the League. And thank you for joining us today for this important discussion on PFAS and drinking water and the new regulations designed to protect residents. I'm pleased to introduce our first speaker, Marcus Cole, Director of Business Development for Pennsylvania American Water. Marcus brings extensive experience in water quality, compliance, and environmental protection, including nearly 20 years with the Pennsylvania Department of Environmental Protection. So Marcus, I will turn it over to you to introduce your team.
Okay. Thanks, Jennifer. Appreciate that. I'm going to share my screen here. Hopefully that all works. You all should be seeing the presentation now. Again, I will thank the Municipal League for their partnership. I also want to thank HRG. We partnered with them on this presentation to bring you some engineering technical knowledge as well. But greatly appreciate the opportunity to be here with you today to talk about this topic. Thrilled to see the turnout. Thrilled to see a few familiar faces, from my former career. So hopefully this topic is of interest and valuable. I'll say at the outfront that we did design this presentation to appeal to all levels of understanding for this topic. So for those of you that have a pretty in-depth understanding of what PFAS are, the beginning of this may be a little bit, rehash of those information, but I think that everyone on this call, regardless of your level of understanding, is going to come away with something. So really appreciate that. So today there'll be three of us that'll be speaking to you primarily. That is Brandy Braun. Brandy is our Director of Water Quality and Compliance. She's been in that role for about 3 years, doing a fantastic job in making sure that all the water our customers drink is meeting all standards and is as good as we could possibly deliver. Justin Mendinsky, he's Assistant Vice President at HRG, Water and Wastewater. HRG is a statewide engineering firm, and really appreciate Justin's participation on this and the addition that he's going to give. And then again, my name is Marcus Cole. I'm with Pennsylvania American on the business development side, and really happy to be able to speak to this audience today and provide as much information, as many answers as we possibly can. So today we're going to cover some of the system challenges, first starting with what are these PFAS, kind of what is PFAS, how do they impact, how did they get there, those sort of things. What are the current regulatory requirements, both at the state and federal level, as well as, what do we see for the future? And then we'll go into detail about treatment options and the cost of compliance. And then finally, we'll talk a little bit about ourselves and how we believe we are experts in this field and some of the things we've learned in the process. So with that, I'll turn it over to Brandy Braun to more completely introduce herself if there's anything I missed. But again, looking forward to the rest of this conversation.
Okay. Thanks, Marcus. Yep. Hey, everybody. Nice to be with you today. Brandy Braun. I do have the privilege of directing our water quality environmental compliance team for Pennsylvania American Water. So it's all things regulatory compliance for drinking water, wastewater, lead, and cross connection. Before I joined American Water in 2017, I did work for a local municipality in Pittsburgh, PA. So, I have some perspective on what it takes from, a bigger company like Pennsylvania American Water or a smaller utility to meet these new up and coming regulations. We've mentioned PFAS. It's also known as PFAS. So when you talk about this large group of manufactured chemicals, it's well over 3,000 individual chemicals that make up this group. That's referred to PFAS. We'll get into the two individual compounds a little bit later. But so if you don't have knowledge of these chemicals and you're thinking, where do they come from? We interface with them in some form or fashion really every day. They are man-made. I think the biggest is in like water repellent clothing, cookware that is, non-stick. I've also seen that it's in like packaged microwave popcorn. So really, if you start investigating where these chemicals are, they're in a lot of the household products that we use every day. Unfortunately, they do not break down easily, and that is why they're being looked at by EPA and PADEP, because once they're in our water, it's really hard to get them out. And at this point, when you work for a water utility and you're pulling water from a surface water source or a groundwater, you're not safe. It could be in either. So we really have to pay attention to what's around our sources and see where our potential impact could come from. The health effects, they are being studied, and unfortunately, they have been linked to cancer and reproductive issues. I'm not sure if anybody has watched the Netflix special on these chemicals, but it's all about DuPont, and it came out in 2018 if you're interested in that. So that's a little bit of a background of just why these chemicals are important, but where do we stand? So PADEP did take the initiative to put in regulatory requirements before EPA. So I don't know if anybody on the phone, how much experience you have with UCMR, which is the Unregulated Contaminant Monitoring Rule. In 2021, EPA announced that they were going to do the 5th sampling round. And that was in 2021, and they established 29 PFAS contaminants plus lithium. So out of the 3,000 that I said, which make up PFAS, they chose 29. So water utilities, they started sampling in 2023. The sampling for UCMR 5 went from 2023 to 2025. It really depended on the size of your system. But PADEP is typically ahead of the game, and they started their research actually in 2019 to develop a sampling plan for water utilities. And then on January 14th, 2023, PADEP decided to establish their own regulations ahead of EPA. So that's kind of why Pennsylvania is ahead of the game, and we started our sampling, and we have data to really help the water utilities figure out how they're going to protect their customers from these contaminants if it was detected in their water sources. Initial monitoring for water utilities in Pennsylvania started in 2024. So if you are part of a water utility that served greater than 350 people, which is not a lot, then you started your quarterly testing in 2024. For those very small systems that serve less than 350 people, they started their sampling in 2025. The initial requirement for water utilities in Pennsylvania was 4 consecutive quarterly samples. What we've ran into is that, especially at the beginning of this, since Pennsylvania was ahead of the game, is there was a shortage in labs that were able to test for these contaminants. And PADEP does offer a list of certified labs. On their list, it's only 24 labs across the country that are regulated or certified to run PFAS sampling, and only 4 of those are in Pennsylvania. So depending on your local resources, what you need from those labs, this testing can be expensive. For just the tests, it can range up to $800, but that doesn't include potential sample collection, supplies,
I'm
transport of
not prepared
samples.
because no one told me they were coming. And I was
So I'll just make a note that might want to make sure that everybody, yeah, there we go, is on mute. Thank you. So testing is critical, and it can be expensive for smaller water utilities or even bigger water utilities that did not budget for this new testing. So the two PFAS compounds that we know are PFOA and PFOS, so PFOA and PFOS. And the regulations that PADEP set were 14 and 18 parts per trillion. But in case you're wondering why out of the 3,000 contaminants and then the 29 that were focused on in UCMR5, why did they pick just 2? Why PFOA and PFOS? Well, I looked up some information on the PADEP website, and there were published toxicology reports and studies as of 2022 that showed these 2 compounds were the most common and persistent PFAS chemicals that were detected in the human body. So that's how we came to focus on these. In Pennsylvania, since all water utilities have completed their initial monitoring for Pennsylvania compliance, now we have the requirement, if we violate and we have values over the 14 and 18, that is a tier 2 public notification, which means within 30 days, we have to let our customers know, hey, we've detected these contaminants, we are out of compliance, we are figuring out a plan to remove them from your water source. We also have to include these results in our consumer confidence report. So if you've ever heard of an annual CCR or an annual water quality report, all water utilities are working on that right now. We must include these results to let our consumers know what we've detected, if we've detected anything in our sources. So that's a very high level of where are we at in Pennsylvania specifically. So my last slide is I just want to talk about future. Where are we going? And I will admit that there are a lot of unknowns, right? So in Pennsylvania, we still have to make sure that we comply with our PADEP regulation. You know, their regulation is still in play, even though we have to look at the federal rule and see what EPA is implementing. That's not going away. PA did not adopt the federal regulation yet until they figure out, what the final rule is going to be. So again, just going over the timeline, PADEP started their research in 2019. We started UCMR5 sampling between 2023 and 2025. But then PA has established regulations as of 2023. In April of 2024, EPA announced the limits for the 2 compounds, PFOA and PFOS, at well below what Pennsylvania was prepared to meet. I think we all can agree, there is a huge difference between 14 and 18 parts per trillion and 4 parts per trillion. So I think just being in the water industry, it was a lot of anxiety on our compliance department and on our engineering department to try to figure out what are we going to do, right? We made sure that we were in compliance with the PA regs, but now we have the federal rule that we have to start planning for. So that's kind of where I think we all sit collectively today is what are we going to do? How are we going to continue to provide good quality, safe drinking water to all of our customers, meet these new regulations, plus figure out treatment for anything that is elevated, and do it in a tight time frame. So the main thing that we have to remember is we did do initial monitoring in Pennsylvania, but the EPA is also requiring initial monitoring for their regulation, and that sampling must be completed by April 1st of 2027. So what that means is PADEP gave water utilities an opportunity to submit data by the end of December of 2024 to be considered as part of EPA compliance. But if you did not analyze for both PFOA, PFAS, plus the 4 additional compounds that EPA had included in the hazardous index, then you have to make sure that you go back, pull out all your results, and make sure that you have results for those additional 4 compounds. If not, you will need to make sure that you start your initial monitoring over to comply with the EPA regulation. So what that means, it's a little bit different now. So for systems that serve over 10,000 customers, by April of 2027, you have to be sure that you have 4 consecutive quarters of samples that have PFOA, PFAS, plus the other 4 contaminants that they've included in the hazardous index. If you are a system that serves less than or equal to 10,000, you only have to have 2 samples that are 5 to 7 months apart. So I think that's something for all of us to just make sure that we have all of the required data so that we're in compliance with the EPA regulation for whenever we hear the final decision. Even though there was a recent announcement that there are thoughts that they may remove those 4 additional contaminants, there's been no mention that I'm aware of that those are not required for initial monitoring. So like I said, please go back and talk to your water utilities, or if you're at a water utility, and just make sure that you have all the required compliance data to be prepared for this regulation. Initially, thoughts were that we had to have that sampling done by 2027 and a plan for treatment by 2029. I think it was good news to all of us that they're thinking about extending it to 2031. Again, we haven't heard where we stand on that, but it is concerning no matter what size of your water utility. Treatment's not easy. And Justin's going to talk about that in a second here of what are our options. At Pennsylvania American Water, we do have 1 system with treatment right now, and we're using GAC contactors. And it is a smaller system, but with that came an extensive permit. So I want all of you to be aware when Justin talks, he's going to give you your options, but know that PADEP, when they issue your permit, you will have numerous special conditions that they do require a lot of attention from your operations staff, from your compliance staff, to make sure that you're doing all of the required testing. And when you do change outs, there's additional sampling requirements, both monthly, quarterly, and yearly. Plus there are arsenic and pH requirements. So it doesn't end with just, figuring out a solution, putting some carbon in, and then you're done. This is something that we're committing to. This is something that if you have UV or have ever heard of UV, that just takes a lot of attention from the water utilities. And we'll get there collectively, because I think we're all in this business because we want to do what's right for our customers. We want to protect our resources, protect public health. But sometimes it does come with some stress and some cost. So Justin, I'll pass it off to you to talk about what the options are. Thank you.
Thank you, Brandy, and good morning, everyone. I appreciate the opportunity to join my colleagues here today as part of the presentation. As Marcus mentioned, my role at HRG is as our Assistant Vice President of Water Wastewater Services, a role that I've held for a little bit over a year now, but I've been with the firm for over 21. And I do profess myself as someone to have a love for water and wastewater treatment. So I could probably get into the weeds here pretty quickly and spend more time than we have available. But my goal is really to provide what I would say is a high-level overview of what the options are that are available for treatment treatment. As Brandy mentions, PFAS is really, considered an emerging contaminant, and the regs are relatively new, of course, as she mentioned, and obviously even still changing, as she did a great job of suggesting there. But what we are finding from a treatment perspective is, even though it is something that's become in focus just recently and is again kind of newish, if you will, in terms of having limits established, the treatment technologies that are, being identified as those that are efficient at removing PFAS are actually those that have been widely available and used in the water treatment industry for a number of years, obviously just on other parameters of focus in the past. So that's good news, I think, that obviously the things that I'm going to talk a little bit about here today, maybe some of the folks here that are joining us have some familiarity with. However, given consideration to the new regs and what are obviously some pretty low limits, the things that we're trying to remove here with these PFAS compounds, those are some pretty low limits. You really got to do a heck of a job treating it to get down to those levels if you happen to have a high concentration. So there are some considerations that I wanted to jump into today, just to help guide you in your planning, your design, and your permitting activities. So on the screen here, a couple of bullet points. There's 3 technologies that are really my prime focus for discussion today. Brandy obviously just mentioned a little bit about GAC, or granular activated carbon, and that is one that is a primary technology being used in Pennsylvania. So we're certainly going to focus on it. The 2 others here that I've mentioned are ion exchange and reverse osmosis, and I have some information about each of these systems that we'll dive into here in just a couple minutes in my subsequent slides. Kind of important to note here, these are probably the 3 that are most commonly thought of right now and are actually making their way into some of the guidance documents that are put out by the regulatory agencies. However, there are manufacturers and treatment technology providers that continue to look for new solutions. So by no means is this really meant to be the all-encompassing or the comprehensive list of technologies that are available. There are certainly more that are out there. Really is a benefit to work with your engineer, work with a manufacturer, just to identify if there are other options than the ones I'm going to dive into. As noted by Brandy, there's a lot of different compounds that make up the PFAS category of emerging contaminants. So really important to understand, as she mentioned, what's in the water, what is the particular compound that you might be looking at for removal, because the selection of the treatment technology can certainly be greatly impacted by that. And one of the last things you'll note here before I advance the slide, I did mention PFAS and biosolids on the bullet point there, and that's not really a particular point of emphasis during our presentation here today. We're obviously focusing more on the drinking water side of things, but I suspect that there's probably some folks here that are operators of wastewater facilities, or you might represent a municipality that does own and operate a wastewater treatment facility. And we do know that PFAS is showing up at the wastewater plants, as you can imagine, really is predominantly something we're seeing in the biosolids. And though the regs are not yet, in Pennsylvania at least, focused on those wastewater treatment plants and showing up in things like NPDES permits, we do see right now when those facilities are going through their permit renewal process, they're having to do some of the testing that Brandy mentioned and should try and figure out what's in the influid, what's in the solids, and obviously what's passing through the treatment plant there. So just a little bit of a heads up, if you will, that ultimately we may see some of these regulations we're talking about here today on the drinking water side start to become more prominent on the wastewater side. Next slide. So to dive in a little bit on treatment here, just wanted to give some overall thoughts relative to the regulatory agencies that we primarily think about with PADEP and EPA. They have certainly put out a number of guidelines, if you will, how to achieve the limits that are being established and providing suggestions for the types of treatment that will help the water systems ultimately get to compliance. But ultimately, they don't necessarily dictate what the treatment needs to be. So these regulatory agencies, they rely on, the experts, so to speak, the operators of systems that know their facilities and can certainly provide guidance on the types of treatment technologies that might be applicable. Consulting engineers such as myself and others, they're really the ones that are being relied upon to come up with the appropriate technologies, to have things sized and to make sure that they're implemented to not only meet the PFAS requirements here and the limits that we're talking about, but to make sure that all of the requirements of the water treatment plant are being met. So just a few notes here again. DEP, kind of a common theme here so far with the GAC. That's really what we're seeing has been permitted in Pennsylvania as a form of treatment. It's something that's been used for a number of years. It has a lot of uses. It removes a lot of contaminants from water systems, and ultimately, again, has been permitted in a number of installations. I'll talk a little bit more in a number of slides and get into some detail about pilot tests, because it's really important to think about doing a pilot test. It's actually required for PFAS, but anytime you're looking at a water treatment system, piloting is certainly very beneficial. And EPA, kind of similar, if you will, to what I just mentioned. They're not dictating how the water systems remove the contaminants. They're not specifying a certain type of treatment, but yet are certainly releasing a number of guidelines and documents that will help water systems or consulting engineers, anyone who's needing to look at treatment, gives a lot of guidance on how you can go about the design of those systems. One quick thing, the last bullet point here on this slide, we're talking here about treatment, but I guess I'd be remiss to say if you happen to be a system that has a number of sources, you're blessed with having perhaps multiple groundwater sources or maybe even multiple surface water sources. One thing that can certainly be looked at is the ability to perhaps abandon one of those uses, and instead of implementing treatment, perhaps you can still maintain your demands on your system with treating other sources, or maybe not even having to do any treatment. I'm a person who tends to think that water is an extremely valuable resource, so I hate the idea of abandoning good wells, and certainly in the future, as perhaps drinking water becomes more precious or more scarce, it's not something that I would jump to right away, but be remiss again to not mention that might be an option for compliance. Not a lot of time meant to be spent on this particular slide, but the take-home point, I guess, if you will, here, there are a number of different organizations, regulatory agencies, of course, like EPA, but professional organizations that have been kind of at the forefront, if you will, on identifying the treatment technologies and helping to provide guidelines for what we need to do with these emerging contaminants. Again, utilizing a lot of technologies that have been around, but definitely getting into the weeds a little bit and how you would go about sizing. What kinds of tests do you want to be running on your source water or your finished water where you're thinking about treatment to make sure that you're implementing the right technology. So, good Google search will certainly help you to find those. There's a few shown on the screen here, and for sure many, many others that I did not list, but just wanted to kind of, I guess, provide a little comfort that there are those agencies out there looking to help all of us through this, if you will. So I mentioned here a couple of minutes ago about pilot testing. And again, pilot testing I find to be extremely important for any type of water treatment system. Of course, with PFAS being new, if you will, with the regulations, I would certainly recommend it. In fact, I don't just recommend it in Pennsylvania, it's required in Pennsylvania. So I'm going to jump into that a little bit here. Some of the benefits, if you will, about doing a pilot test, you really get the opportunity to kind of try it before you buy it, if you will. Your operations staff can learn a lot about what kinds of things they might have to do to maintain a system. What are some of the pinch points, if you will, in the operations? And then that really helps then to translate into a better, I think, fully designed project and a full-scale implementation. So PADEP has released a number of months ago now what they referred to as a preliminary draft PFAS piloting and design standard. I was just checking again to see if it's still listed that way as a preliminary draft, and I think that is the case. It is ultimately intended to be incorporated into the Public Water Supply Manual, the Part 2, which is the Community System Design Standards. And candidly, that's kind of one of the key guides, if you will, in terms of how water systems need to operate when they're serving the community. So this document may ultimately, whether it's in entirety or portions of it, will be implemented into the Public Water Supply Manual there. And it does provide guidelines for the piloting and design standards, primarily for those three that I've already mentioned, and that will be the focus of the rest of the presentation here. Next slide, please. Some of the other things, I guess, to keep in consideration with respect to pilot testing, particularly with the PADEP. So pilot testing and applications and protocols to go about doing that, those have been around for a while. I have a little bit of a snippet here, if you will, on the screen, and just meant to show that the DEP standard pilot study application is really still applicable even for these new emerging contaminants of PFAS. So if anybody's ever had the opportunity, I say that as opportunity, maybe you don't feel that way, but if you've had the opportunity to go through a pilot study of some level, you would still follow through with a lot of the same type of application, a lot of the same types of forms. Particular to PFAS, what we're seeing here now with PADEP, really are seeing a timeline for the pilot study requested to extend for a period of 9 months. And really, what that provides is an opportunity to see if there's any variation in that source water. A lot of times we will see that over the course of the year, whether it's the change in seasons, maybe it's even change in different types of environmental or weather events that happen, that can change the source water. So by extending that pilot study for a period of 9 months, then we tend to see any changes that might be happening throughout the PFAS treatment there. Are there things that we come up with that we know might change those parameters? And that's really why we want to see that done for such a long time. But part of this is really taking a good comprehensive look at that feed water, analyzing all the different parameters which might be in that feed water to understand, are there any types of contaminants that might compete with the treatment technologies for the effective removal of PFAS. Things that we want to really, I guess, flush out through the pilot study are things like, how do you size the system? Things such as empty bed contact time, which really relates to the size of the vessels if it's a pressure vessel. Or what's the hydraulic load, and when do we start to see breakthrough of PFAS, recognizing that might be a time where we have to swap out the media. And then ultimately, at the conclusion of the pilot study, the production of a final test report is typically performed. And ultimately, that summarizes all the things that we know are of concern during the course of the pilot study, shows the effectiveness of that pilot unit, the treatment technology that was being utilized. Hopefully, we'll identify at that point that we've been able to achieve all of the limits that are set in place, not just for PFAS, of course, but making sure that all the limits of the treatment plant continue to be maintained, as I mentioned earlier, and again, providing some good information about the expected operation and maintenance of that unit and potentially cost considerations as well. Digging in a little bit more, if you will, on some of the different types of systems that are available for pilot testing. I've got a little bit of a photograph, if you will, here on the screen of one that, again, I kind of think as a plug and play unit, if you will. This is a relatively smallish unit, but you can kind of see it's compact, can be brought out to the site on a skid, and really, requires some kind of minor, if you will, improvements at the plant to be able to operate the pilot. So we've got to bring some type of plumbing to it to get our source water through it. We have to plumb it to the waste source as well. So whether it's the sanitary sewer or whatever else is being utilized to direct the wastewater away from the pilot system, and electricity. So, these are becoming more and more prevalent, if you will. There's a number of manufacturers that are looking to, sell their equipment, right, and making these pilot pilot units available. So they're out there and available. Candidly, you can look at the screen here and you see some of the things that are associated with this pilot, are readily available materials. We've got some, perhaps it's PVC tubing for the columns. We've got a number of different valves. So if one is not necessarily available from a manufacturer, well, it can probably be something that a local contractor procures the materials and builds on site. So this would be, I think, probably representative of something for a groundwater system, a smallish one. They can certainly be a lot larger, and perhaps for a larger source water system or like a river intake type system, you'd want to use a larger pilot system. But just to show that, not all of these are necessarily extremely large. But some of the things we do need to keep into consideration, the location of it. Some facilities, quite honestly, are blessed to have a building that has enough room to be able to bring in a small treatment unit such as this. Not a big deal. However, our firm is currently working on some groundwater sources that really don't have any type of room within a building, even for something as small as what we see on the screen. So therefore, we got to look at a system that might be available and come in more of a enclosed trailer unit, something that's got heat, got power in it, and takes a little bit more work, if you will, to implement into the treatment system. Some of the other considerations here is locating where that feed water will come from. So where exactly in your treatment process will you be able to pull the water from? Power, we obviously need to get electrical power to these units. There's a number of different instruments. There's a number of different valves and controls. So being able to power those is obviously important. And with any of the systems that we talk about, wastewater availability. So one of the downsides of having to treat for PFAS and remove it from the source water is that it ends up somewhere. And usually that's in the wastewater. So we've got to give some consideration to how we handle that wastewater stream and divert that away from the drinking water treatment facility there. Next slide, please. Just some other considerations that we're seeing here and want to be mindful of. I recognize that not all drinking water systems are similar, both in size or complexity. We're not a hat, right? All of your systems are a little bit different. It's not one size fits all. So we want to recognize the fact that surface water systems, when it comes to PFAS treatment, are certainly different than your groundwater systems. What we're seeing here for the surface water type systems, they're generally going to be larger. And I think that's pretty self-explanatory in some respects. If you're utilizing a surface water, say coming from the Susquehanna River, or the Delaware River, or the Schuylkill, some of our main ones here in Pennsylvania, you're probably doing so because you have a relatively large demand, and you can kind of understand that therefore a PFAS treatment system for that type of surface water system might be a little bit larger than, say, a smallish groundwater source. Again, I mentioned the type of PFAS that's targeted for removal. That's certainly important. Go into Brandy's discussion on testing. That's where it's beneficial to really understand the types of compounds that are in the water, and then we can be sure that the type of treatment technology that we're investigating is suitable for removal of that particular compound. Concentration and flows, those are obviously extremely important to the selection of a treatment system. If you have a highly concentrated PFAS source, unfortunately, meaning you have a lot of PFAS in the source water there, well, that could lead to larger pressure vessels combined with a higher flow. Certainly you expect to see potentially larger pressure vessels, but also just the rate at which the treatment media is depleted and that change out will have to occur is certainly going to be greatly impacted by that. The ability to incorporate the treatment into the current plant is certainly of critical importance. We have to do a good job looking at the hydraulics. We got to make sure that those pressure vessels that we have to implement, if those require new pumps or if they require a change in the treatment scheme up gradient, well, we have to take that into consideration. And of course, the other objectives we want to keep in mind: what's the water quality that we want to obtain? Are there any other types of parameters of concern, such as interference? What's the operation and maintenance? I know we're going to end our presentation today talking a bit more about some of the costs that we're seeing here. And of course, as I mentioned, the backwash waste disposal of critical importance. I'll have to speed us up perhaps a little bit. Again, I mentioned I love this kind of stuff, so I could probably get into it all day here, but I know my stomach is getting a little hungry, and I'm sure most folks are too. But I did want to drive into a little bit of particulars for each of these. So again, the GAC, granular activated carbon, it's been around for a long time. Typically, we see this used in a pressure configuration. So we're showing a couple of contactors here by a specific manufacturer. These are pressure vessels. Don't know if they were installed in an existing building or if that building around it had to be constructed particularly for these, but gives you a little bit of a visual what they look like. I know when I was a young engineer, one of my first projects in water treatment, I had done some iron and manganese treatment via green sand removal, and those vessels look very, very similar to the ones that we see here on the screen. Some kind of key things, though it might be not extremely clear to everybody, but there's a number of different sample ports that go down through the course of the bed there that allow the operator to collect samples at multiple levels, see what that PFAS concentration is as you work your way down through the GAC column. These are again typically supplied with a number of different instruments and valves, such as flow meters or electrically operated valves that can be pre-programmed in terms of when they open and close and initiate backwash cycles. A lot of times we'll see these installed in a lead lag configuration, meaning it'll go through one vessel to the next and therefore continue to remove PFAS through each subsequent stage of the treatment. If it requires multiple passes through to achieve your objectives, that can be done. But a lot of times when one needs to be taken out of service to replace those carbon media beds, you can still achieve your treatment by keeping just one of them in service there. And again, as I mentioned a number of times, the GAC very commonly used for a number of different parameters, and I think pretty widely accepted throughout the industry, lends itself well to PFAS. A couple of different things on the slide here with respect to advantages and disadvantages of this particular treatment technology. I won't hit on them all, but obviously one of the big advantages that we look at with granular activated carbon, we're finding it works pretty well, right? And that's pretty important. If we have these new regs and we have to treat to these pretty low levels, we want a system that's going to be able to reliably achieve that. And that's what we're finding with the GAC. Pretty reliable removal and doesn't necessarily pose a risk that you're going to spend all this money, so to speak, and end up with still having PFAS at the end of the day. They can require a pretty large footprint, though depending on your flow rate, maybe they're not necessarily as large as that photo I just showed a couple of slides ago. There is an opportunity to retrofit conventional sand filters to utilize the GAC. But again, I think what we're seeing predominantly is that these are going to be in more of a pressure configuration in those types of steel contactors that we showed there on the previous slide. Some of the disadvantages with the GAC, because of the fact it does work so well at removing a number of different compounds from drinking water, we are finding that there can be some competitive adsorption. So if you have a surface water source that's really laden with TOC, it's going to do a great job at removing that TOC, but ultimately that might be eliminating some of the PFAS removal efficacy as the TOC or those other compounds start to take up those pores, if you will, and absorb onto the GAC. Quite honestly takes up some of the spaces that the PFAS would be removed by. And O&M, really for all of these systems, I think we're going to find that the O&M costs are pretty substantial. And, folks really need to properly plan for that and, make sure there's really no surprises, if you will. With the GAC, when ultimately that media is expired, you have to go ahead and replace it. And that's a cost both to dispose of the spent media, but also that labor and the cost to bring in the new media. Next slide, please, Marcus. Anion exchange, I'm just going to jump right into this. It's a very similar type of technology, utilizing most times pressure vessels, but the media, if you will, within the vessels is different. So instead of having those activated carbon beds, it uses a selective resin, which is trying to reach out, if you will, and grab those PFAS molecules and attach to them, and therefore keeping the PFAS from going through in the treated water. This has also been used for a number of years for water treatment. Some of my clients have used anion exchange for a number of years on nitrate removal, and that process works very well. So they're very familiar with this type of technology, which again lends itself to PFAS removal. So pretty similar, if you will, in terms of like the makeup of the system. You got those large vessels, if you will. You've got the number of different instruments and automation with the valves. Some of the disadvantages, again, are kind of similar with all these systems. We're going to see some increased O&M maintenance when we have to replace the spent resins here. There's the cost associated with that. Just like the GAC, there's a waste stream when you go into a backwash mode, and we have to ensure that we're properly disposing of it. And a lot of times that's going to pass down to our wastewater treatment facilities. And what we are finding is that the ion exchange resin on a pound for pound basis, if you will, is a little bit more costly than the GAC, though we see a little bit of a reduction in the resin that's necessary. So kind of a trade-off there that we have to keep in mind when we're doing our economic evaluations. And my last technology, a particular look here for you today, nanofiltration and reverse osmosis. So these types of systems operate much differently than our GAC or our anion exchange. Rather than trying to adsorb onto a GAC grain or to have that selective resin to pull the PFAS out of water, these systems operate by utilizing very, very small pores in what I'm saying here is a semi-permeable membrane, and using a high pressure to push the water through, but looking to exclude the PFAS molecules. So it's a very, very small opening. You use pressure to push the water through, and all the contaminants that we're trying to remove basically get blocked from passing through. But ultimately those then accumulate, and just as the other systems, we need to address the waste stream from those. Nanofiltration, reverse osmosis, again, technology that's widely used and is being found to work pretty efficiently at a number of different PFAS molecules. Advantages, as I just mentioned, it's been around, it's been used, it's effective. Disadvantages, I think I've hit on those as well. One of the downsides is it does create that concentrated stream that's going to be heavily laden with PFAS. That's going to have to be discharged and addressed. So something we have to keep in mind there. And a lot of times what we find with these systems, because we're needing to push the water through such a small opening, it requires a lot of energy to do that. So some larger horsepower pumps, perhaps the way those have to get implemented into the treatment technologies will change something that's already existing in the plant. So we do see these as being a little bit more energy intensive, and therefore increasing the O&M costs specific to electrical power consumption. A couple more slides and I'll turn it over to Marcus here. But just some of the things that, we're seeing here, both at our consulting firms as well as providers such as Pennsylvania American. What we're seeing here, surface water systems, they're proving to be a little more challenging when it comes to treatment. And I think that's just really due to the size of the facilities and the types of demands and the flow rates that we're talking about when it comes to surface water. And also the fact that you can see variation pretty quickly in surface water. If you have one heck of a rainstorm and you've got some flooding conditions, that water quality changes very rapidly and can certainly have a great impact on that treatment system. The costs are definitely higher, what we're seeing here for the surface water systems, because of all those factors. Hydraulics, again, I've mentioned that. Really need to take a good look at the plant hydraulics to ensure that the implementation of the PFAS treatment system doesn't negatively impact something downstream from it. So could result in a change of pumps or something that then passes that to the storage or the distribution facility. Really have to take a good look at that and understand the hydraulics of that treatment system during your pilot study. And I believe it was pretty well mentioned by Brandy at the start here, GAC becoming more of a standard, if you will, for the folks on the presentation here with me, just because we're seeing low fouling and some pretty good performance in the pilot studies and in those fully implemented systems. And last thing for me, some of the other things that we're finding with these systems in themselves, these different technologies are pretty intense, right? There's a lot of things that we have to bear in mind when we size them, some factors for considering how to size it appropriately, the waste concerns, all of that. But then there's other things that we're realizing are kind of challenging too, if you will, that we wouldn't necessarily think of right off the rip. Accessibility concerns. So these are some pretty large vessels potentially. Where do we put them? And how do we get to all the accessories that are on those? So we think about things like access and catwalks to be able to get around safely. The last thing we want to be doing is relying on the old extension ladder propped up against one of those steel tanks and someone trying to get up to an air release valve. So those are the kinds of things we need to give consideration to, making sure we have safe access to all the different components, and we certainly don't put our operations staff in harm. Automation is key for these systems, being able to rely on something that can automatically initiate a backwash, open and control valves to reduce the labor and someone having to really pay attention to when that should happen in a manual fashion. We want to be sure that we have the right amount of automation and controls. Influent flow meters, we're finding operators really prefer to see those. Most of these systems are typically equipped with a flow meter. If it's a pressure vessel like the GAC, for example, a lot of those are going to be equipped with a flow meter at the bottom, which is on the outlet side, if you will, of the contactor. But a lot of the operators are finding that they prefer to see flow meters into each of the vessels, helps them understand the treatment through each, and helps them to make sure that they're able to dial in a little bit better. And one of the last things here, some of these large buildings in themselves, we think about what are the materials that are needed and how the heck do we heat these buildings, and times like we have currently with 5-degree weather when we wake up in the morning. So we don't necessarily always give consideration to the HVAC or the ways to maintain a building. But when you're putting in these large contactors, we're obviously seeing that that's something that can raise the O&M costs. And Marcus, I believe I'm turning it over to you on the cost here.
All right, thanks, Justin. We'll let you catch your breath. I do appreciate Brandy and Justin giving a very detailed overview of the complexity of this rule and the solutions to maintain it. I'm going to cover costs. Hopefully, this is of interest, and I'll try to speed up my presentation to make sure we have maybe time for a question or two. But as you can see here, cost estimates vary greatly. Anywhere from $1.5 billion from EPA when they finalized the rule to, American Water Works Association estimate anywhere from, about $4 billion to over $5 billion. Keep in mind that these estimates are a couple years old. And as we all know, things have only gotten more expensive over the last few years, and demand is peaking, right, as additional systems are needing to add treatment. So while these estimates are huge numbers, keep in mind that they may even be higher at this point in time. Notably, we're looking at a significant amount of that in initial capital costs, and there is some federal funding available to communities for that, but recognize there is not nearly the amount of federal funding that there is as far as need goes. And that funding is for capital costs for the construction of these facilities. It doesn't take into account annual operation costs, which skyrocket the cost of this. And in the next slide here, we'll get into the cost to customers, right? So a recognition that this is going to be a challenge for systems to figure out how to do all these things from a technical basis and then pass those costs on to customers. And as you can see here, those smaller systems anywhere under probably 5,000, that's a very significant cost annually per year. And again, this is solely for the PFAS side of things. This is not taking into account increasing power costs, always increasing personnel costs and chemical costs. So there is a significant cost to this for customers, and I think we're going to see rates increase pretty dramatically as a result of this. This is something that systems should be aware of and recognize this challenge. And so, this is a local decision, quite frankly. I was intending on, if there was a little more time, kind of asking folks to raise their hand if they were aware of what their treatment level or their PFAS level was, and start doing that. But essentially, these are questions that you need to wrestle with. And as Justin and Brandy, I think, highlighted, this is a really, really challenging situation, one that a local community can really struggle with, especially a smaller community. And so, there are options, there are treatment, and a lot of systems are going to choose to add those treatment and work with local engineering companies in order to add that. There are others that may shut down wells or purchase water. And we see that as a viable option, and Justin certainly mentioned that. And then, for other communities, just wanted to make folks aware that, Pennsylvania American is a potential partner there as well. This is something that we do very well, as I'll move on to the next slide, which is we've got experience in dealing with PFAS. As Brandy noted, we have an active system in our Berwick facility, in our Frackville facility that we've been operating for some time. We're working on numerous other facilities, both on the groundwater and surface water side of things. We've got a ton of experience, and we recognize that there is a significant investment that is needed. Sometimes that investment is even too great for a smaller system to take on, realizing that those costs get a lot larger as you have a smaller customer base to share those over. So, just a little bit about this, and Brandy covered it in fairly great detail earlier, but we have been paying attention at Pennsylvania American and American Water for years to this issue, certainly prepared, and we believe that we are experts in the field, really proud of the expertise that we bring, not only from our water quality team that Brandy manages and our engineering team that helps design these solutions, but also our extensive research and development and sampling, that we've done, the data that we maintain. So we certainly believe that we are experts in the field, and for anyone that just has questions and wants to bounce those off us, certainly we're willing to be of help. Finally, just a little bit more about us, if you're unfamiliar, and this is a kind of a way to introduce Pennsylvania American to you. But we are the largest wastewater and water provider in Pennsylvania. We serve about 19% of the Commonwealth's population. We have facilities statewide with our largest hubs in the Pittsburgh region, Scranton-Wilkes-Barre region, and in the Harrisburg area here, primarily on the west shore of Harrisburg. So something that we do every day. We are water and wastewater professionals. We wake up every day and live and breathe water and wastewater. Finally, just to give kudos to Brandy and her team, and something that sets us apart as a company is our commitment to water quality and environmental compliance. We have a large team that is solely focused on that. Brandy does a fantastic job leading them and makes sure that, as she articulated and Justin kind of supported as we deal with some of these emerging contaminants, that we are protecting public health. We are making sure that the water our customers drinking is of the highest level. I'll say before I wrap up, and we maybe have time for one question, that PFAS is but one challenge that these municipal systems are facing. There's also competing regulatory new regulations on lead service lines, and that is requiring replacement. And we anticipate there are more and more stringent regulations coming. We hope that in the future we can continue to partner with Pennsylvania Municipal League to educate the members about some of these additional challenges as well. But I guess with that, I will thank everyone for bearing with us. I know we've lost a few along the way. Some folks couldn't stay away from lunch, and I don't blame them for that. But do appreciate everyone that hung with us throughout this time. we do have time maybe for one question. So I don't know if anyone has one, but if you do, please raise your hand. We'd be happy to answer any questions you might have. Right. Looks like we may have done such a thorough job, and I could have taken 2 more minutes to explain my slides. So shame on me for that. But again, we greatly appreciate everyone being available. Dan, your question is, will the slides be available? Yes, it is our understanding that the presentation will be posted to the Municipal League's website. Jennifer, please correct me if I misstate anything.
And I will send out a link to all the attendees as well, so you'll have that recording.
Excellent. Thank you, Jennifer. Thank you all for dialing in. Again, really appreciate everyone listening in, and Brandy and Justin for helping to provide a ton of information to you all.